Started. Good day, everyone, or good night, as the time zone might be. Welcome to an Aarna Networks webinar. Today, we are going to cover a demo and a presentation on the Aarna Networks ONAP distribution 3.0, and we call it ANOD for short. So let's jump in. So, Sriram, I guess you'll have to move the slides. Next slide. The speakers today are me, Amar Kapadia. I'm a co-founder at Aarna Networks. I'm also the author of ONAP Demystified and Understanding OPNFV books. Both of these the ebooks are available for free. And my co-founder, Sriram Rupanagunta, is the other speaker. And Sriram is an NFV specialist with a background in OpenStack, Ceph, storage, and data plane acceleration technologies. Okay, next. So in terms of the agenda, what we are going to cover is what is ONAP. I know for some of you this might be repetition, but there are many people on the webinar that are not familiar with ONAP. So for those that are familiar with ONAP, apologies in advance. This might be a little bit repetitive, but we'll quickly cover what ONAP is. Then we'll go through Aarna Networks ONAP distribution 3.0. Sriram will give a short demo. We'll talk about some next steps, and then finally we can have some Q&A. Okay, next. So what is the problem that we are trying to solve? Next generation services are going to require automation. So what does that mean? In a software-defined world where you have NFV, SDN, MEC, or edge computing, this will definitely require management and orchestration in a standardized way. You cannot, it'll be too dynamic an environment to do sort of ad hoc or partial automation, partial orchestration, and lifecycle management. Next is automation. Because these services are going to be so dynamic, you cannot have human beings fixing issues. If you have 10,000 edge clouds with 5G network functions, MEC applications, analytics, etc., there's just no way you can have some human being fix an issue at this scale. So the monitoring, analysis of the monitored data, and closed loop automation has to be fully automated. Third, all of this has to be done in a vendor agnostic way. If every vendor has their own mechanism of doing orchestration, lifecycle management, and automation, it'll be like having thousands of remote controls in the house. It's just not practical. So for this reason, it needs to be a standardized solution that is vendor agnostic. So with that problem statement, you can go to the next slide. We believe the ideal solution for this is ONAP. Now I realize I haven't gone into what ONAP is, but let me just hit some high points. In terms of the features, the key features are there's an easy to use design studio in ONAP, orchestration and lifecycle management functionality, and then real-time policy-driven closed-loop automation. So with these features, the benefits are you get a lot of architectural innovations with ONAP, which we will talk at least superficially. You get the major benefit of no vendor lock-in. And you will see that ONAP has tremendous momentum and network effect. Now, this network is not to be confused with networking. Network effect simply means that it's a virtuous cycle. So what it means is as more operators use ONAP, more VNF and PNF vendors embrace ONAP. And as that happens, even more operators use ONAP. And you can see that kind of network effect going on with ONAP, specifically with third-party standards and open source organizations. And we'll talk more about that as we go along. Okay, next slide. Okay, so now I'm going to spend a few slides on what is ONAP. ONAP is a Linux Foundation networking open source project. And as per their website, ONAP provides a comprehensive platform for real-time, policy-driven orchestration and automation of physical and virtual network functions that will enable software, network, IT, and cloud providers, so pretty broad, and developers to rapidly automate new services and support complete lifecycle management. So this is essentially what I talked about when I set up the problem statement. Okay, next slide. In terms of some of the history, ONAP is almost 2.5 years old. It was started in March or April of 2017. It resulted as a merger of AT&T eComp. AT&T open sourced their eComp platform. And there was a prior Mano project in Linux Foundation called OpenO. They merged and became one project, 100% open source, part of Linux Foundation. We talked about it. And you see the operators that are behind ONAP. And you've probably also seen the statement that the operators behind ONAP represent over 70% of worldwide mobile subscribers. So in terms of this sort of covers the momentum piece of ONAP, tremendous operator participation. If you look at, I don't have a slide on contributions, but contributions from 30 organizations, it's a fairly vibrant project. Okay, next slide. In terms of the functionality that ONAP offers, if you put it in an ETSI framework, this is not the ETSI framework per se, it's a modified ETSI framework. And what you see on the left-hand side is the data path. So you see the hardware. On top of that is virtualization software, which could be containers or virtual machines. You have virtual storage, overlay networking, data plane acceleration. And on top of that, you have the actual workloads. Workloads could be arbitrary microservices, edge applications, can be analytics, AI, ML, inference engines, and of course, network functions are sort of close to our heart. And then on the control and management side, on the right-hand side, you have the VIM, the Virtualized Infrastructure Manager, which is Kubernetes or OpenStack. And the one that is in the light blue, meaning the Kubernetes, the hardware, virtualization software workload, you'll have many of those. And then what's above that, you will generally have centralized with pieces in each cloud. So there you have the global orchestrator. It can be NFVO or MEC orchestrator, MEAO. Then you have application manager. VNF managers are the corresponding manager for MEC platform. You have SDN controllers. You can have global SDN controllers for connecting data centers, or it can be within the data center for network virtualization. And then on the right, you have the critical piece of monitoring and closed loop automation. And above that, you have OSS, BSS, e-services, and big data. So I don't know if there's animation, but let me just talk about it. So ONAP covers the global orchestration functionality. The app manager, it can either work with its internal app managers or it can work with external. It has the global portion of the SDN controller and the monitoring and closed loop automation framework. So for that reason, a lot of times you will not see the term Mano in any ONAP website or collateral, because it's really much more than ONAP. It's, it's much more than a Mano. It's sort of Mano plus plus. Okay, next slide. So in terms of the scope, we already covered this a little bit, but there are two broad pieces of ONAP. There's the design framework and a runtime framework. In the runtime framework, you have orchestration and lifecycle management functionality, the classic ETSI Mano functionality. But over and above that, you have monitoring and real-time closed loop automation. And the way this works is all the telemetry that you want goes into ONAP. So whether it's events, metrics, logs, alarms, all of that goes into ONAP, into a sub-project called DCAE, Data Collection, Analytics, and Events. DCAE analyzes the telemetry through an big data analytics pipeline. And the output of that goes to a policy engine. And then the policy engine then drives the orchestration or lifecycle management side of the house, one of the service orchestrator or one of the controllers. So that's how you get the real-time closed loop, policy-driven closed loop automation. In addition to all of this, ONAP also has an inventory service. The inventory service is single source of truth. It tracks everything that ONAP is touching, whether it's virtual, physical, subscribers, and the database is a graph database, so all the relationships are also tracked in addition to all the active and available inventory. So that's the scope of ONAP at a high level. You can go to the next slide. In terms of how, that was the internal view. In terms of the external view, how ONAP interacts with other systems. Southbound of ONAP, you have the NFVI and Vim. And here, it's basically OpenStack and Kubernetes. Although other platforms might come up over time as well. Azure Stack is supported by ONAP, and that might come up over time. And then you also have, ONAP has an SDN controller, but it can also talk to southbound SDN controllers. So those are the southbound interfaces. Northbound, you have OSS BSS, big data. So if you want to put your telemetry into a data lake and do some analytics applications, batch analytics on top, you might have some of those applications. And e-services are nothing but portals where end users can go to and request whatever services they need without talking to any human being. So completely self-service approach. So that's northbound and southbound for ONAP, and the interfaces are fairly standardized. Southbound is OpenStack or Kubernetes. Northbound, there is alignment going on with TM Forum, with Sol5, and MEF. So the idea is to make it standards and open source compatible. And on the left, you have external modules and artifacts that ONAP interacts with. There are many, some of the ones are listed here. VNF packages, or could be PNF packages, analytics applications, external SVNFMs, external element management systems, etc. So those are sort of on the side. So that gives you an idea of what ONAP interacts with. Next slide. This is the official architecture diagram from the Dublin release. And I'm not really going to go through it today, but what you see is roughly 30 active projects. And you see on the left, you have the design time, all the blocks in dark blue. And the main project there is service design and creation, a GUI-based unified design studio, which is very easy to use. The whole idea is that non-programmers should be able to interact with ONAP. The right-hand side is the runtime set of projects. And you see the service orchestrator SO. You see a variety of controllers that it talks to underneath it for lifecycle management and other aspects. So you see multi-Vim/cloud, SDN controller, application controller, virtual function controller. And then for telemetry collection and analytics, you have DCAE, data collection, analytics, and events. And that then feeds to the policy framework. And then you also have for inventory services, active and available inventory. So that's a very quick view of ONAP. There are other northbound interfaces as well, GUI screens that are available, but we are not going to cover that in any depth today. And then southbound, you have the NFVI, Vim, SDN controllers, third external systems, etc. Okay, next slide. So ONAP brings a lot of functionality, and that is quite exciting. But I think another very important thing about ONAP is it also brings new architecture principles to the table. So the first, there are several architecture principles. We have chosen the top 3 according to us. The first one is model-driven. ONAP, to the degree possible, uses models everywhere. And what that does is it allows automation, it allows the modification of platform behavior without requiring software skills. So you don't need to hard code or do any programming to change the behavior of the platform to drive automation actions. So that's probably the number 1 innovation that it brings to the table. Model-driven also decouples you from software release cycles. So previously, if it was hard-coded, then you would have to wait. If something didn't make it into the Dublin release, you would have to wait for the next release before you get that functionality. With model-driven, you can be decoupled from cycles. Cloud native, ONAP itself is cloud native, and it also expects VNFs to be cloud native, and ONAP also now supports CNFs, which are cloud native network functions, which are container based. And finally, ONAP uses a CI/CD methodology for its own development and also manages VNFs using a CI/CD flow. So it expects that VNFs will be changing constantly, and it's not that every 18 months we can do a nice organized upgrade. You'll be getting different VNFs changing at different rates, and ONAP is built for handling that. All right, next slide. So why is ONAP interesting? What are some of the differentiators? So in my opinion, the single biggest differentiator is the real-time policy-driven closed-loop automation framework. That is extremely powerful, and I believe that differentiates ONAP with respect to all other Mano platforms out there. Second differentiator, it's simple to use. The design tools are very simple, and the whole idea is whatever can be done without requiring engineering should be possible, and that opens up ONAP to a lot more people as opposed to just having programmers who can work on it. There's a global SDN controller integrated. So we talked about that. So not only can you do NFV services, you can also do SDN service orchestration through ONAP. ONAP is rich enough that it can not only do NFVO and VNF manager functionality, but it can also do the same thing on the MEC side, MEC application orchestration and MEC platform manager. ONAP has Kubernetes support. This is a huge differentiator against other competing projects or proprietary products. ONAP's support for 5G is evolving, but it's going to be extremely robust and comprehensive. And I feel that ONAP will end up being a de facto automation solution for 5G. And finally, ONAP is open source. Okay, next slide. So why is open source important? So the first thing is it is being used as a reference implementation for open standards. So this is where I talked about the network effect. And one of the network effects you see is third-party open standards like TM Forum, like MEF, like ETSI, like 3GPP. They're all using ONAP as a reference implementation because it's open source. And what that does is, as more of these standards bodies and third-party open source projects use ONAP, ONAP becomes more compliant to those standards, and that ends up in greater adoption. So I think that's probably the single biggest value of open source. The second is high probability of meeting operator requirements. There's a vibrant end user advisory group in ONAP, EUAG, that constantly provides inputs, and those inputs are used to prioritize what gets done. So as opposed to that, in a proprietary product, you would have to go through sales, who would then talk to product management, who would then talk to engineering, and who knows whether your requirement makes it or not. Assured interop. So ONAP has Interop program. It's underneath something called OVP, and it's a Linux Foundation driven community-based Interop program. So VNFs and PNFs that pass that program are assured to interoperate with ONAP. Faster innovation, that's one of the benefits of open source. What you have in an open source community is people from different points of view. You have people who know hardware, you have people who know operating systems, people who know Kubernetes, people who know 5G, people who know SDN and NFV. And these people can innovate faster than in a proprietary, in a single company, where you don't have that same breadth of skill sets. Roadmap influence, as an end user, you have a lot more ability to influence open source roadmap. Reduced lock-in. You can have multiple vendors supporting ONAP. If you don't like one, you can switch to another. I'm not saying it's a zero sort of effort, but it's much less than switching from one proprietary product to another. And then transparency. Everything in ONAP is transparent. What features people are working on, what commits get accepted or rejected, how their testing is done, the code itself, everything is open and transparent. What people are discussing in various meetings. So there is no way a proprietary product will give that level of transparency. So for those reasons, open source is useful and important. Okay, next. So now we'll switch over to ANOD. So introducing Aarna Networks ONAP distribution, we call it ANOD 3.0. So this is our third release. We started with Beijing, then we had one for Casablanca, and now for Dublin. What's unique in this one is this is the first release for which we are offering commercial support. The previous two, we did not offer commercial support. So we will cover what that means. We also have, this is also the first release where we have an enhanced version of the ONAP installer, OOM. We call it Aarna OOM. It's essentially OOM with automation and GUI. And that's what Sriram is going to demo. And 100% pure play open source. We are not doing any forking or downstream development of ONAP itself. And it's 100% open source. Okay, next slide. So this gives you a visual description of ANOD. So in the middle, what you see is ONAP. We already looked at the block diagram, so I'm not going to cover it, but it's 100% pure play ONAP. Below that is Aarna OOM, and the whole idea is to make ONAP easier to install and manage. We've had customers and partners who said they were working on ONAP for literally 3 to 4 weeks and unable to install it. And with AOM, they were able to install it in half a day. So that's really the value there. And on top, we are going to have our proprietary apps and artifacts. So things like workflows, directed graphs, policies, analytics applications, anything that you require to make the platform work is going to be proprietary, and that's we are going to call Aarna Stream. Okay, next slide. This just gives a little bit deeper view of ANOD 3.0. What you see is, it doesn't include all the projects yet. So we have chosen a subset of projects that we are supporting for now. Design time, of course, we are supporting fully. And then on runtime, you can see we have chosen a subset of controllers and a subset of projects that we are supporting. And below is Aarna OOM, and on top is Aarna Stream apps and artifacts. Okay, next slide. So what is Aarna OOM? Let me take a stab at it, and then Sriram, maybe you jump in and you can explain further. So it's built on top of the community OOM. So it's not like we have done something completely proprietary. It uses a model-driven approach. In being consistent with ONAP in general, we also decided that for Aarna OOM, it's very important to be model-driven. That also allows it to be used in a CI/CD approach. We want to make day zero installation easy, repeatable, and reliable. Once you have all the nodes provisioned with the right operating system, AOM takes over. There is flexibility in Kubernetes reference architectures, or you can use customer-provided Kubernetes. It allows flexibility in what subsets of ONAP to use, streamlines ONAP configuration and health checks. And roadmap, we also want to make day one operations simpler as well, like reconfiguration, scaling, upgrades, cluster changes. And it's Aarna OOM will support both GUI and an API approach. Anything else you want to add, Sriram?
Yeah, I think there are a couple of slides where I can go through a little bit more in detail. Once you continue.
Sounds good. Okay, so we can go to the next slide.
I think.
So I'm not going to go through this in a lot of detail, but what this is trying to show is that everything we do on ONAP will be done upstream. So it's 100% pure play open source. So it shows the master and how the community cuts releases, and all the patches that we work on, whether it's for new functionality, bug fixes, security fixes, will be done upstream. And then ANOD will basically take all of that from upstream. And that's why it's 100% pure play open source. Next slide. So ONAP contributions, we are fairly active in the community. In terms of code itself, we helped upgrade APSI in El Alto to Open Daylight Fluorine SR2. And you can see us on the list of contributors. For now, we are not sort of high on the list, but we hope to change that. But in addition to the APSI work, we are also very active on OVP, which is the Interop program from LFN. So at ONS in September of 2019, we showed validation scripts for compliance and validation for heat-based VNFs. And at the Linux Foundation Networking Developer and Testing Forum that's coming up in January of 2020 in Prague, Czech Republic, we are going to lead a VNF hacking track. So any VNF vendors are welcome to come to that event, and we will help them with OVP interop testing. Additionally, we are also supporting the Linux Foundation, it should say Linux Foundation Edge, apologize for the mistake, LF Edge Akraino ICN blueprint, integrated cloud native blueprint. That's a blueprint where ONAP, a subset of ONAP is being used to orchestrate all the workloads that you might see in an edge environment, 360 video, EdgeX Foundry, AI/ML inference engine, and SD-WAN network functions. So that's a pretty interesting use case where ONAP is being used. And then finally, OPNFV VCO 3.2 is a 5G blueprint. Right now, it doesn't use ONAP, but once they're done with phase 1, we will help with ONAP integration. Okay, next. As I mentioned, we have support subscriptions available for ANOD 3.0, Premium and Basic. Premium is relevant for production, it's most stringent SLAs. Basic is relevant for dev test activities, it's sort of 8x5 medium SLAs. And what do you get with support subscriptions? You get expert assistance and issue resolution. So any problems that come up, we help fix that, fixing defects, updates, tech bulletins, community advocacy if you have specific features you want to put knowledge base. And the support is for 1 year for a particular release. And our expectation is that in this new world of DevOps and CI/CD that within 1 year, customers will upgrade to a newer version of ONAP. And we can provide support subscription just for Anode platform only, which is essentially just ONAP, or Anode plus Aarna Stream. And Aarna Stream covers all the things that go in the platform to make it useful. As we discussed, things like workflows, directed graphs, policies, analytics applications, collectors, et cetera, et cetera. Okay, next slide. Interop strategy, we are not going to have our own Interop program for now. We are going to rely on the community Interop program, which is OVP. And the logic is there just aren't enough resources in the industry to do every permutation of vendor Interop. So if every vendor wants to work with other vendors and every operator wants to do their Interop testing, there just aren't enough people. So we are focusing on OVP, and we are also going to rely on HC plug tests for Interop testing. So between OVP and HC plug tests, we have done testing with 5 vendors, which are shown on the right-hand side. And as I previously mentioned already, we are running the, it should say January 2020, January 2020, DDF Plugfest OVP VNF hacking track. Okay, next slide. What use cases are we supporting at Anode? The primary one we want to support is 5G and Edge, MEC. And we realize that for this, we may have to wait till the Frankfurt release for full 5G support in terms of network slicing, but that is our strategic direction. Additionally, BBS and CCVPN are the 2 major NFV-centric use cases that we will support. And then from a pure SDN orchestration, we are also supporting PNF use cases. Surprisingly, a number of our customers want to use ONAP to manage PNFs. Okay, next slide. So with that, I'll hand it over to Sriram for a little bit more description of AOM and a demo.
Hi, everyone. So we're going to show the demo of the installer that Amar talked about. So, but before getting to the demo, let me just give a little bit of introduction of what the problem is, what we're trying to solve, and what we're going to demonstrate. So the problem statement is that despite all the simplifications, what we keep hearing is that it's still very difficult to deploy and use ONAP. So even though OOM provides a very convenient way to deploy using containers, it's still difficult because there are a lot of combinations, a lot of possible ways of deploying it. So, and this happens to be one of the barriers that we have seen for the more widespread use of ONAP. And that's especially true for those who are new to ONAP, both VNF vendors as well as the operators. Now, so what's the solution, right? So we have 3 ways of making this easier, right? One is we can deploy using some of the automated scripts. Fairly convenient. They give you a lot of flexibility in managing different combinations. There are few manual steps, but it's compared to, let's say, just using the open source version of OOM from the community. This makes it a lot more simpler, right? The second mechanism is a fully automated way of doing the deployment using Ansible playbooks. So at the moment, we are keeping it as internal and it's not documented. So this essentially takes away a few of the manual steps that are there in the first mechanism and makes it fully automated. And the third one, which is what we're going to show in the demo today, is using the GUI-based installer, the ANOD installer. And this is again a fully automated model-driven approach. There is a visual representation of the deployment progress And as Omar mentioned in the previous presentation, there are few features that we would like to add in the subsequent releases, which are currently not there. For example, the options to upgrade, downgrade, essentially do the entire life cycle management of ONAP itself. Not the VNS, but the ONAP itself. Right? And another interface that we would like to provide is also to have a REST interface so that some of these operations can be automated. GUI-based approach, which is what we're going to show in the demo today. So essentially, as we talked about, it's deploying it with a GUI, and it's a fully modeled. There is also visual representation of the progress, and also ability to.
Srinam, your voice is going in and out.
Okay. Let me adjust the mic.
Can't hear you right now.
Is that better, Amar?
Yes, much better.
All right. Okay. So yeah. So essentially, also to an ability to look at failures and look at the logs and so on. So these are all the visual tools that are provided by the installer. So some of the goals of the installer, again, I'm not going to go into all the details of this. It supports both bare metal as well as the cloud-based deployment. For example, you can deploy it on GCP. The second point I'd like to mention is the model-driven. Similar to the philosophy of rest of ONAP, itself can be model-driven, where the user can select the type of model, or they can even define the model of how they want the ONAP itself to be deployed. This shows the block diagram of the installer itself. Let me just show the full screen mode. So the installer itself is a set of containers that we have developed as a web interface. And
hey, your voice is still going in and out again.
Okay, is that better now?
Yeah.
Okay. The Ansible scripts essentially are the ones that do all the heavy lifting in terms of deploying it on the server. So this talks about some of the components that are used. Again, I'm not going to go into all the details of all the components, but essentially it's a Docker technology with Nginx, React.js, and XP. Use MongoDB to store the state of the deployment so that the deployment can be upgraded or downgraded for all the LCM operations. So what we're going to show in the demo today is what we call as a very simple model 0. This essentially deploys ONAP on a single server without any HA features. And it assumes that there is already an OpenStack that's installed on the same server. So it's essentially what we call as a all-in-one. And it deploys it as a multi-node cluster. So all the VMs inside the server essentially form the Kubernetes cluster, and the ONAP is deployed on that cluster. So that's the demo that we're going to show today. All right, now with that, so let's switch over to the demo.
Are you sharing? Share?
Yeah, I'm going to share it.
Okay.
All right. Can you see the screen, Amar?
Yes.
All right. So what we're going to do is first start the installer itself, which is the script that I'm just showing right now. So this starts up the containers, which essentially provide the web interface. So you can see that the containers have started, and it shows the URL where the installer is available. And once you click on the URL, that's the main screen of the installer itself, and that's the dashboard. And as I mentioned, you can do multiple deployments from a single installer instance, which is running on a jump host. So now we're going to start a new deployment that we're going to call it Dublin HPE 26. And you can give the description of the deployment. So as you can see, what the important thing here is the model type. So in this case, we are going to show it, deploy it as a model 0. And then for model 0, it will ask for the relevant information, which is essentially the username, the IP address, and the SSH keys. So these are the minimum parameters required. So essentially what you have done so far now is to kick off the deployment process. And this is all happening on the host that we just gave the details. So you can see the action button here. And that's the one which, once you click on that, essentially it starts up the deployment. So you can see the deployment, the name of the deployment, the description, and the model. And as I mentioned, you can have multiple deployments from this dashboard. And that's pretty much it. That's the only action that you'll have to perform to do the deployment. And now it goes and deploys on the server. We're not going to show all of that because it takes about 45 minutes or so to deploy. So now we can see that the ONAP portal is up on the server where we've deployed it. So one other additional point is that in this particular model, we deploy all the components of ONAP. So we did not allow the user to select only a subset of the components, but there are other models that can be defined where you can support only a subset of the models. All right, so that brings us to the end of the demonstration of the ANOD installer.
Okay, great. Do you want to go back to the slide deck? I think we have just one last slide, and then we can wrap it up. Or I can share. That's, I can also share.
Okay.
Okay, so next steps, we would encourage you to try out ANOD 3.0 on, you can try it out on Google Cloud Platform for free. If you just go to arnanetworks.com/products, you'll see a place where you can provide your information. You will get access to. If you want to try it out on bare metal, then please contact us. If you are not quite ready to try out ONAP, but are curious to learn more, you can take a look at the book, the free ONAP Demystified ebook. And finally, if you would like ONAP training, either just for yourself or for your team, then you can request that. If it's just for yourself, you can just tell us your name and city. And if we have training in your city, we'll let you know. If it's for your team, then also just you can indicate so. And as long as there are 5 people, we will have an on-site instructor-led training. So that brings us to the conclusion of this webinar. Thank you so much for attending.